Alright folks, today we are going to be talking about quadrilaterals. Quad, of Latin origin, right? Quad is four, and the word lattice in Latin roots means side, right? So quadrilateral is just four sides, okay? So we have different types of quadrilaterals. Some of them you definitely recognize. So we have the rectangle, and those are defined as all angles are 90 degrees. Opposite sides are equal, right? So this side is equal to this side, as you can see why it's colored in different colors, and this side is equal to this side. Now, if I never talked to you about these tick marks, if you see something like this, that would also tell us that this side is equal to this side, and this side is equal to that side, right? And you can see the square. They chose to do colors here to show you all sides, but you can also do tick marks, and this is what a square tick marks would look like right there. Okay, so you can see that all sides are equal, and then all angles are 90 degrees. And I'm pretty sure you know what a square is. So a new term that you might not know as well would be a rhombus, also known as a diamond. All sides are equal. Okay, so you can, if you've seen tick marks on these, this would how the tick marks would look. And opposite sides are parallel. Okay, so this side is parallel to this side. And this side is parallel to this side. Okay, so this side's parallel to this side, this side's parallel to that side. All right, moving on. Color back. Parallelogram, opposite sides are parallel and equal. So they're equal lengths and they are parallel, right? So this side would be equal to this side. Again, the tick marks kind of show us that they are equal. They use colors. So this side is parallel to this side. That means that from any point on here, these are equal distance apart. Kind of like railroad tracks are always parallel, right? If you deviated from a parallel system on railroad tracks, well, what would happen to the train? Well, one of the wheels would fall off, or both wheels would fall off, right? And the train would just be sitting on the wooden stacks in the middle. So we have a trapezoid. Two sides are parallel. Okay, so trapezoid, two sides are parallel. You see the red. You see the other sides are not parallel. Now these would eventually intersect, right? If you drew these onward. And then also the parallel lines will never intersect, ever, ever, ever. They are equal distance apart at all times. And then another term that you may not have seen, a kite. Now, kite that you're probably remembering would be like this. Well, that's just the upside down version of that, right? And so this is called a kite. Adjacent pairs of sides are equal, right? So these two sides are equal to each other, and then these two sides are equal to each other. Okay. All right, moving on. You might want to reference this page as we go through today. So we're going to identify some polygons for a warm-up really fast. This is a trapezoid. Feel free to push pause so you give yourself a chance to warm up that brain. This is what we call a parallelogram. Parallelogram. This is always a hard word for me to remember how to spell. This is a square. This is a rectangle. This is it. What we just got done talking about, a triangle. And this is a 1, 2, 3, 4, 5. This is a pentagon. Right? So polygons mean many angles, right? So you can see that all these have many angles, not just one angle. All right, moving on to quadrilaterals now. We have a rhombus, right? Also known as a diamond. Sorry, my pen was not working. A rhombus. All angles are 90 degrees and all sides are equal, so we call this a square. Now, there's a saying that a square is always a rectangle, but a rectangle is not always a square, right? because we just have to have two sides that are equal, right? And so this side has to be equal to this side has to be equal to this side, and it has to have all equal angles, which are 90-degree angles, right? And so these sides are equal, and all 90-degree angles. So this is a rectangle. All right. These lines, these things right here, that means that they're parallel, right? So this is a way to look for parallel lines. And so we see two sets of parallel lines. And so we're going to call this a parallelogram. Lots of different words in there. And, excuse me, letters. We have two sets of parallel sides, and so we call this a trapezoid. I'm loving my new mouse pen, by the way. And then a new term that some of us may or may not remember from last year, a kite, right? And adjacent sides are equal to each other. All right, so go ahead and pause the video now if you'd like, and go ahead and we will do this part. A blank is a four-sided shape where every angle is a right angle. Opposite sides are parallel and of equal length. All right, well, that would be a rectangle. You'll have to write these in, but I made them so I can just move them. A blank has equal side lengths and every angle is a right angle. That is a square. A blank is a four-sided shape where all sides have equal length. Opposite sides are parallel and opposite angles are equal. That is our rhombus. And oops, I realized that we need the word diamond in here. You won't have that on yours because I just realized. All right, a blank has opposite sides parallel and equal to length. Opposite sides are equal, so a blank has opposite sides parallel and equal length. That would be a parallelogram. A blank has one pair of parallel sides. That'd be a trapezoid. And lastly, we have a kite. All right, moving forward, we're going to classify the equilateral here, and we see that all angles are 90 and all sides are equal. So we would say that this would be a square. We see that adjacent sides are equal to each other, so we would say that this is a kite. Pretty simple, or a couple to do on your own. Push pause if you'd like, or just watch all the way through. We see that all sides are equal, but yet they don't have 90-degree angles, so we're going to say that this is a rhombus. And you might notice that a rhombus just looks like a square that's kind of been tipped over, right? So it's like been pushed this direction, right? Oops, excuse me. Okay, so the square, so it's not 90 degrees, right? This would be 90 degrees, right? But it's been pushed in that direction, right? So just like a square, not all 90-degree angles. We have one set of parallel sides and other sides are equal to each other. So we know that this is an upside down trapezoid. And then opposite sides are equal, all 90-degree angles. This is a rectangle. All right, pretty simple so far. Now we're going to look at the idea of measurements, angle measures in quadrilaterals. So just like a triangle, right? We knew a triangle was 90 degrees. If we had a 90-degree angle, right, these would have to be 45, 45, right? Because this is half of a square, right? So half of a square, or half a quadrilateral, so half of a square. and all these angles equal 180 degrees. Well, if you take the other half of the triangle, right, flip it over, and you have a full, right? We have 180 here, and you have 180 here, so those together equal 360 degrees. Okay, so all quadrilaterals will add up to be 360 degrees inside. So all four angles, right? So angle 1 plus angle 2 plus angle 3 plus angle 4 equals 360 degrees, right? And they labeled that up there like that with algebra with the different terms. So each angle will add up to be 360 degrees. All right, so we're going to find the value of x. So we're going to say, well, I'm going to add up all my angles. 115 plus 70 plus 75 plus x equals 360 degrees. Again, all quadrilaterals add up to be 360 degrees. So when we add all these together, this gives us 185 plus 75. And so that's 190, so we have 260, right? Plus x equals 360 degrees. Subtract off 260 from this side, subtract off 260 from this side, and we would say that x equals 100 degrees. Or 100, right? So I got the question yesterday, did we put the degree sign in there? If up here x has a degree sign on it, we do not need it. So otherwise it would be 100 degrees, which we don't want, right? So we just say x would actually be equal to 100, right? If we were entering that into Big Ideas Math portal. All right. So a couple for you to do on your own. So go ahead and pause if you'd like to try some on your own. All right, so here we go. We have a parallelogram. I'm just going to identify it first. A parallelogram, just for extra practice. So we know that's 100 plus 100 plus 80 plus x equals 360 degrees. So we have 280 plus x equals 360 degrees. Subtract off 280, subtract off 280, and we have x equals, let's see, 100, it'll be 80 degrees, 80, right? And we can always check that. 100 plus 100 is 200, 80 plus 80 is 160, 200 plus 160 is 360. We did it right. Right, so again, you can put the angle in there for x and then add up all your angles, and do they add for 360? If they don't, something went wrong with our math. All right, I know what that guy is. That means 90, right? Plus 81 plus 124 plus x equals 360, right? Add all those together, and we get 171 plus 124. We get 592 plus x equals 360. Subtract off 295. Subtract off 295. This goes to 0, and we get x is equal to 65. Again, go up here. 90 plus 124 plus 81 plus 65. Does that equal 360? It should. All right. Draw a right trapezoid whose parallel sides have lengths of 3 centimeters and 5 centimeters. So you need to get yourself a ruler. I'm just going to kind of do this and label it 3 centimeters. Right. I want you to practice with a ruler. Right. So we need a trapezoid. Sides are parallel to each other. This is 5 centimeters. Right. Now, when it said right trapezoid, it means that one of the sides needs to be a right angle. Okay. So actually, I need to do something else right now. All right, so basically I overdrew that line and I need to erase it. So a trapezoid doesn't have to be like your standard trapezoid. We need, instead of right trapezoid, so we need one of the sides to be right, the other side can be like this. The only thing it can't be is it can't be parallel to this, otherwise it becomes a parallelogram, right? So if it was like right here, right, if the line was right here, that would be a parallelogram, right? But we don't want that. So trapezoid can't have a right angle in there. And we say that this one is 5 centimeters. Right? So these two sides are parallel. This 3 centimeters is 5 centimeters. Get out a ruler, give it your best shot. All right, last thing to do is do a couple more exit tickets. So pause if you'd like to do it on your own and check your answers afterwards. So I see I have two 90-degree angles. So I'm just going to say that those are 180 together. Where did that come from? 90 plus 90 plus 118 plus x equals 360. So we have 298 plus x equals 360 minus 298 minus 298, and we have x equals 62. 122 plus 122, I know is 244. Again, just add those together. Save me some time down here. Plus x equals 360. Let me make 52. 302 plus x equals 360. Minus off 302. Minus off 302. X equals 58. Now again, how do you check those? You literally take your calculator, add at this angle, plus this angle, plus this angle, plus this angle. Because we now know this one is 58 degrees. And they should all equal 360. And if they do, give yourself a check. If not, go back to your work. All right. Happy Thursday, everybody. Have a great day.